everyone for having me. So, all about me. So, I'm Ust. I'm the head of analytics at a company called Advancing Analytics, who are a small boutique consultancy based out in the UK. I started my data career a long time ago as an analyst, and then became a BI consultant and have progressed from there. I do have an unusual name. Many people get it wrong, and that's okay. But if you remember the compass direction, you'll always get it right. I'm originally from the southwest of England, spent over a decade in London, and I'm now living in France. I'm not going to do this in French because it would be embarrassing for everyone. But these different experiences have helped me apply a way of thinking differently about very familiar things. I love talking about analytics. I love talking about data in general, sharing ideas and helping everyone get better at it, and as well as having other people give feedback as well so that I can also get better at it. Everything is a learning experience. If you see this guy pop up, it means that something's about to break, and those things that are about to break are usually going to be assumptions. So we'll see this little quick thing pop up every so often. So in the UK, there's an idiom that's the only inevitable things are death and taxes, but taxes change, new ones get introduced, rates change, and death, morbidly, is a change of state from living to dead. Change happens, it is inevitable, or so said Heraclitus. So in the data world, we can contextualize change when the structure of data changes from our dependent system, whether that's a transactional source system or an analytical system, and that effectively changes shape. The instigation of change, regardless of where it takes in the process, will always stem from a change in requirements. So requirements in general, new requirements, updated requirements, they're all going to bring about change. So the impact that this has on data platforms is that change can happen anywhere in any of these different layers. So here we've got a reference architecture. We've got our source systems on the left. We can pull data out and extract it into a landing layer. We can move it through different layers in a Lakehouse environment before then serving it up to our serving and reporting tools. But because change can happen in these different layers, these changes are often dictated by changes in requirements that impact the source systems in which we extract data from, or the changes in requirements that impact our analytical systems and the data we represent to our customers. So managing change is important. We want to have the least disruption as possible for our customers and for you, so that you can stop doing this firefighting. So long time ago, I say long time ago, about three and a half years ago, I was managing a BI estate which had SQL Server integration services running on it, and that thing is fragile. So you have a change in anything that came from source, or even if you had a change in your requirements for your target infrastructure, it would just break. It was complaining about needing to update the metadata. And a lot of the time, myself and my team were just firefighting all these little small bugs which just crept in, which didn't need to creep in, but just because of the fragility of the application itself just meant that it was inevitable. So you want to avoid firefighting, but firefighting is more likely to happen when your source system changes. So what do we mean by that? So it could be that you have a new column. So new field gets added. There's been a change in the business requirement to your source system, and that's going to have an impact in that there's data schema itself changes to store that additional information. Could be that a column gets deleted, that something is no longer required, it becomes obsolete, and it's just being removed. from that application to simplify the structure and to simplify reporting. Could be that it's been modified. So could be a data type. So it might be that it needs to change in length to accommodate any new data. So, for example, a varchar 40 to a varchar 80. Could be a change in field constraints. So things like nullability, or even like formats, or even just having a rename of a column. So like in a product table, it might be name goes to product name. We might also have performance-related changes. So addition or removal of indexes, changes to primary or foreign keys, any potentially normalization or denormalization of those tables, any changes to partitioning or sharding, changes to data access patterns, or any like compliance or security requirements. That doesn't really change what the data is, but it does change how it's provided. So it's not really something we're going to be discussing in this session, but it is an important consideration to just be mindful that changes in how the underlying database will, performance changes will have as you might want to extract data. So as a reminder, changes from sources is that we have maybe new columns, deleted columns, modified columns, or even just performance-related changes to the database. So what we want to do is try to gracefully adapt to that change that occur from our sources. So if we zoom in on our reference architecture, we want to use a tool called Autoloader. This also assumes that there's a little safety barrier, and that safety barrier is the landing zone between our sources and our lakehouse. So it means that data can be pushed however it exists in source into an object store as a file. So Autoloader is proprietary tech. It currently, at the moment, is proprietary tech that exists for Databricks. So it's built around the Apache Spark ecosystem, but it is still quite limited to Databricks. So it consists of 3 different approaches. So storing metadata about what's been read, using structured streaming to process that data immediately, as well as then using more cloud native components to optimize that identification of files. And we've got the Cloud Files Data Reader, which tells Databricks that we need to use Autoloader, as well as the Cloud Notification Service, which tells it to use queues in the background. So Cloud Files Reader is that we want to have a data frame. We tell it to go check the file in the queue. It could also be traversing through the storage as well. And we're wanting to read specific files from source. So it's only going to be reading what the latest is rather than trying to read everything. So if we are to kind of put this into PySpark, we've got the cloud files, which tells Spark to use Autoloader, what format we want it to be. So in this case, we're expecting JSON, and if we want to use the notification queue, to use notifications. If we don't specify this use notifications, it's going to go down like the cardinality route. So in our previous example of our blob storage, it's going to go, well, I've ingested file 1, 2, and 3. File 4 must be what I need to pick up. So the file notification is quick because it uses the queue. Without using that, it's just going to traverse the directory. If you've got a small amount of files and folders, it can be like the performance isn't going to be that noticeable, but it's just another option. So using Azure, we've got blob storage, which is connected to the Databricks. We have an event grid topic, which will monitor the grid or monitor the queue within blob storage and create a subscription for each queue. And Databricks is interacting with the event grid, which interacts with the blob storage queue, so that it's always going to be reading the latest file. So when it moves into the identification of new files, we have a new file arrives. That triggers an event topic that creates the subscription checks for that and inserts into the queue, and then we're able to pull things off the queue into Databricks using the Spark streaming. So with the different config, we've got use notifications, so uses the queue, or we can use directory listing if we don't want to use notifications. Specify the queue name if you want to use an existing one, as well as any connection strings around that. And that connection string is going to be like subscription ID, resource group, etc. However, you don't need to know all of this, or even in fact use most of this if we're using volumes inside the user catalog. In the demo that we'll see in a bit, we're using volumes because it's easier to set up, and it's also a lot nicer and lazy. So when it comes to the benefits of Autoloader, we want to actually use the evolving schemas aspect of it. And when it comes to evolving the schema, what do we mean by that? So we have our initial file. Our file has an ID and a product name, and then the next file comes along, still has an ID and a product name, but it's also got a size. And then if we evolve it again, it's still got a size, but then it's got more details around how we need to care for this product. So there are a few ways in which we can handle this evolution. We can fail the stream. If we detect that there are new columns, we can just say, actually, I'm not expecting new columns, please just fail it. We can manually intervene. So we can say that, okay, we've detected a new column. I'd actually like to add that new column. Let's evolve the schema that way, or we can gracefully evolve it automatically. But in order to do that, we need to know what the expected schema is, what the schema is currently, and how we want to handle that. So we can start with schema inference. So you don't have to specify a schema, but Autoloader and Databricks will store a copy of that inferred schema next to the data. So we want to so we can specify within the Cloud Files Reader the location, so where we want to store the schema, specifying whether we want to infer column types or not, and whether we want to pass through any schema hints. So if we have our file, so it's got an ID, it's got a product name, on that first read, on that inference, it's going to create a schema file in the schema location, and it's going to store that as a JSON object. It does not store this JSON object as nicely as laid out here. It actually just stores it as one single string, and it's pretty nasty to look into. But if we are to, again, if we are to just provide an inference, it's just going to, again, create that file and produce the same thing or something similar. Sometimes it can infer integers as strings. So again, another thing to watch out for. If we specify schema hints, so if we are saying that our ID column is not an integer, it's a long, our same file is going to have a long as opposed to an integer. So there are different options, different modes for schema evolution. So we can add new columns. So what that will do is it'll fail the job and then update that schema file. fail on new columns. So fail the job, but doesn't do any updates. It's just going to alert you that something has gone wrong. Rescue isn't going to fail anything, but will put anything it doesn't expect into a rescued column. And then none is to just ignore any new columns that might exist. So it's a reminder of different approaches to evolution. It's just we're adding new columns, or we can be changing what those columns mean. So when it comes to the rescue, we have our table that's been materialized, and we've got this extra column called rescue data, where it's just storing those unknown columns or those unexpected columns that we hadn't expected on that first read. So if we're adding new columns, it's going to, first of all, remember it's going to fail that pipeline, and then it's going to, and as part of that failure, it's adding a change to our schema file. So it's more of a failure for actually I'm doing something, but you need to restart so I've got the correct schema. Delta can also help with schema evolution. So this is not just limited to Databricks, but for all implementations using Delta. So using Delta, Delta is an open file format for the Lakehouse. So Databricks uses it, Microsoft Fabric uses it, and there'll be a couple of other different flavors that will also use Delta. What Delta provides is the nice things we know about databases like ACID compliance, as well as the flexibility that you get from file formats to be able to just store things in a more convenient way. So using Autoloader, we can take our data from landing and bring it all the way through into our raw layer, into our base layer, and beyond. So that's really where we want to store our data, is in the Delta format. So we could use our streaming architecture to process files whenever they appear. So if we have one file per day, if we have a 24/7 cluster, it's just going to be popping it through whenever it needs it. But if we kind of scale that down, we can then also use the trigger once aspect. So we're running more in a batch mode as opposed to streaming mode. We can also merge our schemas as well. So using like micro batch functions, we can dedupe our data as it's going through. So using a SQL merge or an upsert. So we'll be running a little function inside our stream to update and merge our data. But we can also merge our schemas as well. So when it comes to writing down to Delta, Delta is quite good at evolving the schema of the target file. We have two options. Option on the right to specify to merge that schema, or we can set it in the Spark config so it applies to all write activities. However, it doesn't do it all by default. Its default behavior is to enforce the schema and preserve it from changing. So if you want to evolve the schema, you need to force Delta to do it for you. So with schema evolution, we can have inference and let the engine itself decide what schema it is, as well as having that schema sit next to the data. We can provide hints to what that schema should look like, and we can evolve it through the different options of adding a new column, rescue data, ignoring any new columns, or just filling the pipeline as well. Delta is also quite good at merging schemas, or at least the schemas that it's been told to. What about data types? Again, this is a what the seal moment. So any change to any data type is not currently supported, including expanding a data type. So if we wanted to go from an int to a big int, we couldn't do that. The current approach is to destroy that table and rewrite it. So not just the column, but the entire table. Although that is changing slightly in Delta 4, in that the data type expansion will be supported. So we've gone through quickly what is Autoloader, where does it sit, and how Autoloader can help with change. Before we move on to demo, do we have any questions?
There currently are no questions in the chat. No.
Okay, cool. I will move on to demo. All right. So, I should have done this before. Okay, apologies. We just have to wait for 5 minutes while the cluster turns on. So I'll talk through kind of these first bits already, so we don't have to wait. But what we've got is we want to save down our file into location in the Lakehouse, and we want to pick up our files that we want to ingest through our volume path. So this could be a location in the lake, it could be a mount path, it could be anything you really want it to be, but for this purpose we're using volumes within Unity Catalog. And because Autoloader uses the streaming backbone, we want to specify a checkpoint as well. So we've got some bits to just tidy things up. That's so volumes within Unity Catalog feels a bit like a database, but it's not. It's an expansion to a meta store. And within that we have volumes, so they have file locations that exist somewhere. So they could exist in your Lakehouse, they could exist in the meta store that you specify. And they're just nice to pull from. Will there be words about the copy into statements? It is recommended as an alternative to Autoloader. I'm curious to hear how we could handsomely fail as columns using this mechanism. I hadn't planned to talk about the copy into. Copy into from a transactional perspective is good if you're kind of like nuking a table. So it's an alternative to, I guess, handling things gracefully. And the copy will kind of, there's shallow copies and deep copies. So a shallow copy is going to just reference the data, whereas a deep copy is going to physically move the data. And is it an alternative? Not really. They do different things. They're both methods to get data from A to B. But you might have to have a bit more hands-on coding with copy into, is how I understand it. But happy to be corrected on that one because I'm not quite sure. Oh, it's intent. Cool. I did not know that. I've learned something. Thank you very much, Ben. Right, well, we're still waiting for the cluster to start. But while we're doing that, I'll get these things kicked off. Right, so should hopefully already have one file in our volume, which we do. And if we just read that through, it should look exactly what we've got beneath. So we've got a very simple JSON file, which has not a lot in it. It's got a name, it's got IDs, it's got some descriptive elements. But we can give it a schema. So we can define a schema, and we'll use this as our schema hints if you want to. And we're applying our schema or as our schema hint because you can get some weird behavior, particularly from inference. So for the purposes of demos, I like this to be as smooth as possible. So we've got some config up here and for cloud files, so specifying the safe path and the format in which to read it in. It's going to read it, passing through our config, and then we're going to write it out.
East.
Yeah.
We get the question if it would be possible to zoom in slightly.
Yes.
Ah, amazing. Thank you.
No, hang on. I've used the wrong zoom it command. Was it Control F? Oh, sorry. Someone's going to have to remind me what the movable zoom is. Actually, I'll just zoom in like this because it's going to be easier. Right. Right. So we've written it in. Going to save it. Just check out the save path. So we've got our checkpoint. So where it's saying this is where like the latest file that I picked up from, this is the log, and this is where my schemas are, and then I've got the files themselves. So we at the top we have read 5 rows. We should also see 5 rows. Yep. And then we just want to do a little register of the table. Okay, so we can now in SQL query our table if you want to. Right, so if we upload a new one, what am I doing? Sorry, non-new column, right? So non-new column. So we're expecting a new column, but we don't want autoloaders to do anything about it. So if we read our path again, we have 2 files, our original and a non-new column. So if we read it again, we've got our new column, which is our alternative product number. So we don't want this to appear in our final written table. So we've got our schema revision mode is explicit to be none. By default, schema revision mode is to try and add a new column. So just be a bit careful with that one. So you want to ignore things. So when it's read it, it has not detected it, which is good. And then when you write it down, it should just write down 5 rows with no additional column. So 10 rows and no alternative product code. Right, so if you then use the same approach, but we want to fail it for a new column, we want to hopefully see that it just fails entirely. So same file structure, so alternative product number, specifying here fail on new columns. And it's kicking off the stream, and the stream goes no, because no, that didn't like it. Because it's found alternative product number. So it's also got which can be fixed by automatic retry being false. It's because we specified that we want to fail things when when we detect a new column. So if we check how many rows it's printed, it's ingested, it would say, no, we've not ingested anything. What are you talking about? So we should, again, when we read our table, we just got 10 rows. So it's not done anything. It's decided to fail the pipeline, and we know why it's failed it as well, because it's told us which column it's detected. So we're going to move on. We're going to try and rescue our data. And we're wanting to just set our config to auto merge our schema. So I'm not uploading a new file because there's already a file here. It's not hit the checkpoint, it's not done anything, so I can reuse this one. But we are specifying the rescue. So we have written 5 rows, and we should have 15. And we should, in our rescue data, we've got our alternative product number is now available to us. So if we want to then add the new column, should see in our path. Yeah. And we'll see again that it's got our alternative product number. So we're adding a new column. We're removing our schema hints. Right. So we're removing our schema because it has the schema already, and we want it to evolve. So when we write it down, it should fail for the first time. Oh, fails to merge fields. Oh, great. Okay. Schema hints it is. Okay. So again, it's decided that it doesn't like something. Product ID is string when it should be an integer. So again, word of warning, the inference can be a bit annoying. So let's just put our schema hints. Let's reread that. So our product ID is now an integer. So if we write that again, should fail for a different reason. No, why not? It didn't. Oh, because it already wrote the schema down. Okay. So if it hadn't failed for the first time, it would have failed for the second time. It would have failed for the original reason rather than the schema data type one. But we can see that we've now got our alternative product number as an actual column expressed as opposed to in this rescued column data. So when it comes to deleted columns, it should hopefully just do nothing about it. It should just detect that there's just no data for it.
East, there is a question coming in. From what, when using file notification mode with storage queues, are failed files put back on the queue, or should you retry them manually?
So they're not ever really taken off the queue as such, unless you've got like a clear down mechanism, so like a file, like a retention mechanism. So if it fails, the message on the queue should persist until whatever cleanup operation comes along and takes them off the queue. So you shouldn't need to put them back on the queue. And because the checkpoint will only store the latest successful write position, it's not going to pinpoint that the failed file has already been read into the system. It's not. So you can retry manually, but it should always, as in like retry the stream manually, but you don't need to put it back on the queue. It's going to persist on the queue. Is it possible to reload previously loaded file using autoloader in case if we require? And can we also do backfill of data? So if you want to do backfill for any previous days, yes, you can do. So there is a mechanism to backfill, but again, it's using like the streaming backbone. So you can, there is a command which I think is called backfill, but it's been a while since I've used it, and I haven't got the demo prepared, so I'm not even going to attempt to write it. But yes, it will. There you can backfill data. For previously loaded stuff, you can like also hack it in the sense that you can delete the checkpoint folder and then load everything through, because the checkpoint stores the latest like the latest watermark basically. So yeah, you can backfill in a number of ways. But on to the deleted columns. So our deleted column has removed our alternative product number. Maintaining our evolution nodes. It's done it again. Right. Right. Yeah, data types, annoying. This is very much a what the seal moment. Right, cool. New reds, you should write. Right, our main option. Oh, right, we've broken something. Okay, this is cool. No, it's because I got the wrong key value pair. Right, back to something we did earlier. Missing the S. All right, okay. So you'll notice that Spark is a lazy evaluator in that it's not going to do anything. It's not going to verify that you've done something correctly until it tries to do something like a write or a display. So now we've got the 5, right? So we should see our 25 rows and what we have recently ingested in doesn't have any alternative product numbers. So it's decided it's detected the delete, and that's fine. When it comes to a renamed column, it is going to be very annoying and detect it as a new column. But we can correct that later on. So we got a rename column bit. We can have a look at it. I'm trying to remember what my rename column was. It's only product name. Name product number. Yeah, so we've changed our name to be product name. So being a bit more explicit about it. So if you read again, if you write, so this is what should have happened the first time we tried to add a new one. So it's encountered unnamed fields, product name, which can be fixed by automatic retry. So if we retry to write it, it will then pick up the new file because it's amended that schema. Let's try reading again. There we go. So you need to do the read and the write. Cool. So we now got 30 rows, and we should have, we got our name, we've got these rows in the middle, we've got null against it because we have our product name. So one to watch out for is that rename's just going to get in the way. We've already experienced change data types, so we can, yeah, let's go through it. So data types are always going to be a what the seal moment, regardless of what you're doing. So just be wary of them. So what did I change? So our product ID is a string. And we've seen this quite a few times this evening already. Is yeah, fail to merge fields, fail to merge product ID and product ID because it's the same thing. So again, if we specify hints, it will detect, well, it's not even detecting, we're telling it that it should be treated as an integer rather than a string. And then we'll write down. Okay. So we've had a look at the changes which can impact our system through changes in our application systems. But what about changes in our analytical requirements? It could be a new attribute or measure, we could be deleting something, or we could be modifying it. As we move into our curated or warehouse layer, the requirements of our target data model will change, but we have control in how we respond to our change. So previously we had very little control over how we did it, other than trying to do it as gracefully as possible. Now we've got control. So what we want to do within the Lakehouse is evolve the table whilst maintaining the integrity of any downstream applications. And there's considerations as to do it as to like build time versus run time. So in the good old days, we had schema compare, in which it generated the SQL required to evolve an entire database based upon what has changed between the deployed version and the version in source control. That does not exist within Databricks or in fact any Spark functionality at the moment. And it's something which is fundamentally missing because you don't want to necessarily have to take down everything in order to add a column or to rename a column. You want to be able to do this as gracefully and as automated as possible. So schema compare will do it very much in at build time or deploy time. And what I'm going to show you will evolve your schema at runtime and evolving it through metadata. So we're going to try and replicate some of this functionality in Databricks. So we're going to have a look at adding a new column, altering some columns, and renaming columns. So the control is not just at runtime, but also through the metadata that we provide. Okay.
While the screen is loading, we have another question coming in from Jeroen. Is it possible to infer schema on an already loaded data frame?
Mm-hmm.
The reason is because the source JSON could be nested and you would only want the specific part of the JSON.
Yes, you can do. So you'd want to do this through Well, it's not really inferring the schema on all the reload data frame. So when you load the data frame, it's already inferred that schema. You can provide like the schema hints to it through using like the Spark SQL like endpoints. So there's like with column rename, casting columns as well. So it's a bit more hands-on with how you interact with the data frame. If you want to, in this particular example, extract specific parts of nested JSON, you can start using like the expose functionality within Spark as well. So yeah, you can do it. It's just, yeah, it's more hands-on than being able to do it automatically. Okay. So a few bits to just set things up. So importing all our data types. So if you're doing things properly, you don't want to import star. You want to specify which ones you want. So just strip things. Right. So our original table is just going to be a very simple ID and name column. So you want to try and evolve it by adding, first of all, some comments. So we're adding some descriptions to our columns, as well as adding a new column as well. So we're specifying just the metadata around it. And we have a little function to take this structure definition and convert it into a string which is suitable for writing SQL. So what we can do is we can specify that. So we're just at this point creating a print statement. So create table if none exists. So we've got our ID, which we had before. We've got our name column, and we've got our new comments and our new column as well. So what we want to do is try and compare the two tables together. So we're creating now a comparison table. So we can have a look and have a look at what the original one and the new one should be. So our original one is very simple. It's got nothing. What we intend it to be has more description as well as another column. So we want to try and do this by just basically string compares to be able to make sure that we are getting the right things. So again, functions, so applying engineering principles to be scalable, repeatable, reusable. So if you were to roll this out across many tables, we could just write this one bit of code and just reuse it across multiple times. So this is going to figure out that we've got nothing for rename or removal. We've got a new column that needs to be added, and we've got no change data types again, because data types are what the seal moment, but we do have change descriptions for our schema. So we can now start again adding to this. So we've got an alter column and an add column bit. So again, these are SQL statements that can be issued against the table. So we're altering our table, adding a column, we're adding either a comment, or we're doing other things as well. So it's now going ahead and amending this table. So alter table has been issuing these statements. So if we have a look at the describe, we can now see that our original table has evolved into what our new table, or what we intended our new table to be, without having to go into potentially production system and write alter table, add column, alter column, that kind of thing. So a bit of tidy up, we'll just drop our temp table. So if you want to add a new column and change names of existing columns, you'd think this would be quite an involved and detailed or involved like process. But the principles remain the same, is that we're going to compare the two. So you can have a look. So our original schema is just 3 columns. It's ID, name, and group. And our new, or what we want it to be, is 4 columns, but all prefixed by product. And this is quite, I guess, a nice example in the sense that we're not drastically changing the name of our columns, and we're not adding things which might confuse potential logic to figure things out. So we've got our schema difference bit, but we're also looking for any changes to the rename. So we'll just run this, print it out. So it's not really, so it's found things that are candidates for renaming or removal, which is basically everything that we had originally. And our new columns is pretty much everything. So what we want to do, instead of like dropping all these columns because they potentially have data in already, we want to try and rename them. So we're just going to be using some lovely regex to figure out what has changed. So we got our match columns, and we're saying that actually our product ID was ID, our product group was group, our product name was just name. So our new columns, we now got a new column dictionary, which is going to just pick up, our product color. We don't have any change data types again, but we do have renamed columns. So our renamed columns, they've got a product group and our original column is group, so that when we issue our rename, we're kind of going like, actually, I need to amend the Spark config again so that we can rename stuff. But we've got our, again, it's an alter statement to the table to rename column from our original column to our new column. So if we run this again, we can have a look at. So we're just printing out what it's doing. And then if we describe it, we can see that it has now evolved our table into what we intend it to be. So we've kind of seen how data kind of evolves under our control into our curated layer. And as data is presented to end clients, some of these changes won't necessarily you don't necessarily want to make them aware that you made changes, or at least not yet. So how do we control that? So we control that in the serving layer between our semantic model and our physical tables in the warehouse. And we do that through views. So not these kind of views. These views are great, but they're not the views we were after. We're looking for our SQL views that provide the abstraction needed to keep control. So we have loads of views defined. I'm not going to go through all of them. Right. But because they are views, we can use a create or replace statements. So if we kind of go down to the bottom, create or replace our serving sales 1, we can say, actually, our unit price, we're eventually going to retire, and we can just mark it up or remove our at a later date. So our unit price previously, if we so if you have a look beforehand, our unit price has values against it. So if we run this, have a look, our unit price is now 0. And that means that we can, through the powers of Power BI, start thinking about how we actually track things back out. So if you have a look at our transform bit, so if you're using something like Tabular Editor, this is much easier. For purposes in which I'm now regretting, I'm going to do this through Power BI. And this is where it's now just, come on, stop refreshing. Anyway, you go through the M and start removing stuff, right? What are you doing? Right. It's this one, right? So yeah, so we go through here and just remove it from the M. But again, if you're normal and sensible, you would remove it from using Tabular Editor, so that you then eventually you can just remove it from here entirely and not break things. So reporting, we're going to be pretty similar in the sense that we won't be adding stuff, maybe removing stuff, changing how we display data to people. So we've made some changes to our semantic model. We might have removed some stuff. We might have added new measures. Might have even changed our reporting as well. And if you want to keep those changes from people, we want to use our apps in the reporting layer, and so that we can kind of effectively do like A/B testing. So if we whiz all the way over here, right? So if I go to my app, I've got my sales app, which contains our nice reports. It's nicely formatted. But if I, within my workspace, decide that I want to use the auto-generated report features in Power BI, it's going to produce something like this, which is using different information than what was previously generated. Through my apps, I can change who sees things. And I can do that through the audience in apps. So if I've got in my sales just the normal AdventureWorks ones, if I create a new app, let's call this auto audience. So they're not going to see the AdventureWorks sales, but they are going to see the auto-generated report. Means that I can control the experience within Power BI without necessarily having to rework everything which I've done beforehand. Okay, all right. So Autoloader is great for handling changes from source, but unless it's a change in column name or data type, controlling the schema changes in your analytics applications is where you have full control. Use it wisely. Some people might not appreciate it if you change something which they're using and you haven't communicated that. Experiment with what users can see and do in order to change their behavior. So if there's something you don't want them to use, but they're already using it, start restricting them down so they start using either something that they should be using or stop using it altogether. Don't release changes immediately. Filter those changes using A/B testing, but also just watch out for those what the seal moments, particularly around data type changes, because data types will always trip you up. So thank you very much.